Alright, so this is your crash course video in Units 10 and 12, which is trig related. Trig graphing is Unit 11, and since it's graphing and a little bit different, it's in its own video. So starting off with number 1, just a remembering of how you find missing angles in a triangle. If I wanted angle B, I noticed that based on what I have, sidewise, I have an opposite and adjacent side. So using SOHCAHTOA, that tells me I would use tangent. So I do tangent of B is equal to 4/7. And then in order to solve for the angle, I'd have to undo tangent, so I'd use inverse tangent. Big thing to make sure you guys are aware of, which I had to make my calculator smaller. Make sure your calculator's in degree mode, otherwise you're going to get all your answers wrong. So I'm in degree mode, I do second tan, inverse tan, 4 divided by 7, and I get like 29.7 degrees. Now the directions say to the nearest minute, so if that were to come up, you just hit second apps. Where is it? Oh my goodness. Second apps, option 4, and there you go. So this is 29 degrees and technically 45 minutes, and that's because this is more than 30 seconds. So think about it like a clock. This is not a base 10 system where if it was like 0.5 and up, you'd round up. It's 30 seconds or up, you would round up to the next minute. So 29 degrees, 45 minutes. Coterminal angles are really just helpful when we get into exact value stuff. So just keep in mind that coterminal means they end at the exact same location quadrant-wise. So like 400 degrees, if I subtract 360 from that, I would get 40. So over here, okay, in quadrant 1, opening up in the counterclockwise direction, that would be 40 degrees. 400 would be starting in the same location, going all the way around and then wrapping a little bit more. That's 400 degrees. Okay, so coterminal, add or subtract 360, they end in the same spot. We work in degrees and radians in this course, so if I give you 3 pi over 4 radians, you just need to remember that pi is equal to 180 degrees. Okay, so 3 times 180 divided by, that's 135 degrees. Okay, so that would be going from radians to degrees. Going from radians to degrees when there isn't a pi is when you'd have to multiply by 180 over pi. Okay, so 229 degrees about, we'll say. 75 degrees, 2 radians, I multiply by pi over 180. Notice how that's the exact opposite of what I did in B. And then I reduce the coefficients. So 75 divided by 180. So 5 pi over 12. Okay, and you guys have been doing that since geometry last year. Now what was new this year is we talked about the unit circle. So everything in trig, even graphing, is based on our friend the unit circle, which is a circle whose radius is 1. So that's 1. And it's centered at the origin. Each point on the unit circle represents a cosine of an angle and a sine of the angle, which in this case the angle would be in quadrant 1. And since the radius is 1, that means this coordinate right here at 0 degrees is 1, 0. Then it goes 0, 1, negative 1, 0, 0, negative 1. Okay, and again, each of these is a cosine and a sine. So if this is 0 degrees, this would be 90, 180, 270, all the way back to 360. So like if I wanted the cosine of 90, I would just go to 90 degrees, pick the x coordinate, 0. Okay, so again, every point on the unit circle is a cosine and a sine. So I already wrote that up there. Something else we discussed is our exact value table, which is derived from our special right triangles. So if you remember from Geo, that's a 30, 60, 90, which has the ratios of 1, 2, and radical 3. And then our 45, 45, 90, which is 1, 1, radical 2. So I'm not going to go through the whole derivation. We should know that from what we did, but we always said that there was a way to remember the chart. If you do sine, cosine, tan along the left, and then 30, 45, 60 in numerical order, it goes 1, 2, 3, 3, 2, 1, all over 2, and square roots of the tops, which I don't write the square root of 1 because, well, it's just 1. As far as the last row of this goes, you just got to either memorize it or remember how to derive it. Tangent is equal to sine divided by cosine. So if you were to, let's say, divide these ones with sine and cos of 45, you would just get 1. If you divide these, you would get radical 3. And this is radical 3 over 3. Okay. Keep in mind that these could be in radians as well. So 30 degrees is pi over 6 radians because 180 divided by 6 is 30. 45 is pi over 4, and 60 degrees is pi over 3. So if I wanted to find the exact value of this, I would think pi over 2 is 90 degrees, and then using my unit circle, I go to 90, and I wanted the sine, so it would be the y value, so 1. Cos of pi over 2, so cos of 90 was 0. And then tangent of pi over 3 using my chart would be radical 3. Okay, so that would be 1 minus radical 3 squared. And then you'd FOIL that out, which I'm not going to do. I'll just kind of leave it like that. Okay, so the terminal side of an angle in standard position on the unit circle passes through the point radical 2, radical 2. What is the measure of tangent of theta? So first thing I'm thinking of is radical 2 over 2, radical 2 over 2 is in quadrant 1, because it's in positive x and positive y. Okay, if it's on the unit circle, that means each x is a cosine, each y is a sine. So with that being said, you know that cosine of theta equals radical 2 over 2. So what must tangent of theta be? Remember, tangent's equal to sine over cosine. So radical 2 over 2 divided by radical 2 over 2 is just 1. Now, if we know that cosine of theta is radical 2 over 2, which is what this whole point is telling me, you could do inverse cos of radical 2 over 2 in your calculator, or honestly, just look at your chart. Cosine of what angle gives you radical 2 over 2? 45 degrees. And that would be your answer. Now, it doesn't do it in this problem, but let's just say for a quick second that maybe instead of this being positive, positive, what if I made this negative? What if? How would that change this angle? Well, now my x's are negative and my y's are positive, so this would be your new angle. Which means instead of 45 being over here in quadrant 1, it's now over here in quadrant 2. So that would make this blue angle 135 degrees. Okay, so it doesn't ask that, but that's just an extension of what we've done in class. What if the terminal side of an angle in standard position passes through the point 14, negative 48? What is cos of theta? So what I need you to notice is that that is not a unit circle, because 14, negative 48 couldn't possibly be within a radius of 1 of the origin. So what we need to do is draw a triangle in the quadrant that it's in. So this is a positive x, negative y, so that means if you were to plot that point, it would be there. Which means that in order to plot that point, I'd have to go over 14, down 48. I'm just going to ignore the negative for right now. If I want cosine of this angle, I know cosine is adjacent over hypotenuse. And you'll notice I don't have the hypotenuse. But I can easily solve for that by using the Pythagorean theorem. So I would do 14 squared plus 48 squared equals x squared, and that would give me x equals 50. Okay, so then cosine of theta would be 14 over 50. Now, something you always need to make sure you check, especially in problems like this, is your ASTC chart, which is all students take classes. And you need to make sure that because we're in quadrant 4, we're getting a positive value, which we are. Now let's just pretend for a second I asked you what sine of theta was. Sine of theta would be opposite over hypotenuse, which would be 48 over 50. But since we're in quadrant 4 and only cosine's positive, this value would technically be negative. Okay, moving on. Something else that may come up is SOAR. This is your arc length formula, where S stands for your arc length, theta is your angle, your central angle, I should say, in radians, and R stands for your radius. So on a clock, the length of a pendulum is 30 centimeters. The swing of it determines an angle of 98 degrees. Find the distance traveled by the tip of the pendulum in the swing to the nearest hundredth. So here's my pendulum that is 30 centimeters long and it's swinging. It says the angle it swings is 98 degrees and I want to know how far the tip traveled, so that's S. Okay, I don't know S. They tell me theta is 98 degrees, but remember you need to convert that to radians in order to plug it in correctly. So that means I need to multiply this by 180, oopsies. In radians, I would have to multiply by pi over 180, and then plug in 30 for R. Okay, so I go ahead, I plug it in my calculator, and I get 51.31. Centimeters traveled. Okay, so in addition to sine, cosine, tangent, you guys are going to need to know your reciprocal trig functions. So here they are. Ta-da! So let's say we had the point 34 on the terminal side of an angle. So I'm already thinking, okay, that's in quadrant 1, not on the unit circle. Which means this is 3, that's 4. And I want all 6 trigonometric functions. Well, in order to even get sine, cosine, tangent, you're going to need your hypotenuse. Now, this is a 3, 4, 5 right triangle, so I'm not going to waste the time with the Pythagorean theorem. Hypotenuse would be 5. And then I just go through and do SOHCAHTOA. So there they are. You guys are good at that. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. I just matched up each reciprocal trig function with its matching pair. And all I have to do is flip these. And you'll notice that all my answers are positive, and that's because I'm in quadrant 1. Now, if I took this triangle and moved it to another location, then you just have to make sure that it makes sense in what quadrant that you're in. So, for example, if I took this triangle and, say, moved it here, then using my ASTC chart, I would only have tangent and cotangent be positive. Everything else would be negative. So just be aware. So again, speaking of the ASTC chart, which tells us which trig function is positive where, if I wanted to find a quadrant where sine is greater than 0, which means positive, I would be looking in quadrants 1 and 2. So I'm not looking at 3 and 4. And then between those, if I wanted cosine to be less than 0 or negative, I would pick quadrant 2, because only sine is positive there. Something else that we learned are cofunctions. And what cofunctions are well, they have equal values when their angles sum to 90. So for example, sine goes with cosine, secant goes with cosecant, and tangent goes with cotangent. So notice the co is repeating. And so if I know that cosecant and secant of some angle gives us the same exact value, or some set of angles I should say, then what that means is that these have to sum to 90 degrees. one of the easiest cofunctions you guys should know is sine of 30 equals cos of 60. These are cofunctions, and their angles sum to 90 degrees. So cotangent of 70 would equal tangent of 20, because these are cofunctions, and the angles sum to 90. So I'm not going to solve that. You guys can solve an equation. Okay, finding exact values of things, we use our QRS method. So there you go, all filled in, quadrant, reference, angle, sine. So if I want this tan of 150, I figure out what quadrant that would be in. So that would be quadrant 2. The reference angle would be 30 degrees, because that's its distance to this negative x-axis, which is, again, remember, 180 degrees. And then sine stands for ASTC. In quadrant 2, only sine is positive. So since I'm looking at tangent, the sine is going to be negative. So I can rewrite tan of 150 as negative tan of 30. Then I go to my exact value chart. Tan of 30 is radical 3 over 3, so my answer would be negative radical 3 over 3. And that's exact. I could do the same exact thing in terms of radians. So secant of 4 pi over 3, you would, first let's convert that to degrees just to see what we're working with. So that's 240 degrees. So using QRS, 240 would be over here in quadrant 3 with a reference angle of 60. ASTC, only tangent is positive in quadrant 3, but we're looking at cosecant, which, remember, is related to cosine. That's its reciprocal function. So that's going to be negative. So I'm going to rewrite this as negative secant of 60. I don't know my secant exact values, but I do know my cosine exact values. So I'm going to think about this as negative cos of 60 first, which negative cos of 60 would be negative 1/2. So then I don't want that, though. I want its reciprocal, so then I would flip it. So negative 2 is its exact value. Last thing I'm going to talk about in this video is your Pythagorean identities based on the unit circle. First one being the original, sine squared plus cosine squared equals 1. And then these are derived by dividing through by either sine or cosine. Okay? So using the identities, let's say I give you secant of x is 13 over 12. I want sine. If I look at my identities, sine isn't associated with secant, but it is associated with cos. So that means cosine of this angle is 12 over 13. I'm just going to use its reciprocal. So there's my identity. Now I'm just going to plug in 12 over 13 for cos. Notice how I'm plugging in for all of cosine of theta, not just the angle. So it's not giving you an angle, it's giving you a ratio. So now I go ahead and I solve for sine. Oops, 144. Let's write this as 169 over 169. Okay, then I take the square root, and I'm technically getting two solutions, plus or minus 5/13. That's where this comes in. It says you want an angle that's between 270 degrees and 360. That's just in terms of radians. So if you think about that, 270's here, 360's here, that's in quadrant 4. So you got to ask yourself, is sine positive or negative in quadrant 4? It's negative because only cos is positive. So negative 5/13 would be your answer. Now, technically, if it didn't say using the identities, you could just draw a triangle in the right quadrant. So based on it being in quadrant 4, that would be my triangle. Here's theta. Cosine is adjacent over hypotenuse. And then using the Pythagorean theorem, you could find this missing side. Sine is opposite over hypotenuse, and then you just have to check your ASTC chart. All right, last thing, just some proofs here. Show the left-hand side equals the right. Start on the more complicated side. First thing I'm noticing is secant of theta is 1 over cos of theta. That's a substitution I can make. 1 over cos times cos over 1, those would cancel out to go to 1. Now this is where you need to know your identities. cosine squared of theta plus sine squared of theta equals 1. So if I rearrange this, sine squared of theta would equal 1 minus cosine squared. So therefore, this just equals sine squared of theta. Done. Whew, that was a whirlwind. A lot of stuff to cover. All right, there you go.